Okay, cool. So hello everybody. My name is Patrick Madec, so I'm a solution architect at AWS in Switzerland. I'm based in Geneva. And as it was said, I will talk about Kubecost today, particularly Kubecost deployment within an EKS cluster. So I have some slides to begin with, just to show you why it's important to monitor cost. I guess you are quite aware of this, but let's have a quick look at that. And then I want to show you how Kubecost works, and then we'll go into quite a demo, live demo, to show you how you can monitor cost inside the cluster, but also cost outside the cluster. Let's say if you use external databases, queues, anything that is not deployed within the cluster. So yeah, this is the agenda. So let's get started. So first, why cost monitoring is important. So as you deploy the application in Kubernetes or in the cloud or anywhere, it's always a good practice, right, to monitor the cost when you deploy the application. When you deploy an application, usually it's to tackle some business outcomes, and you want to make sure that your resource usage is optimized and that your cost is optimized, so you can save some cost to invest in other projects or innovate. So it's quite critical for any company to make sure that anything which is deployed is cost optimized. And of course, to pay only for the resources that you need. Then for larger organizations, usually you have multiple teams which are working together, multiple business units, and sometimes you will deploy a Kubernetes cluster which is shared across those teams, those business units. So we talk about a platform which relies on a single or multiple Kubernetes clusters which can be shared. In this case, most of the time you need to show back or charge back the cost to every business unit. So they need to be aware of what they consume. Maybe they have a budget which was allocated, and they need to make sure that what they consume inside the Kubernetes cluster is aligned with the business, the budget which was allocated to them. Then for SaaS provider, and this is more specific to my job because I work with software companies in Switzerland, and most of them are going to SaaS to offer their service as a SaaS platform. And for SaaS provider, which are deployed using Kubernetes, it's really important to understand the cost of each tenant, each customer which they onboard in their SaaS solution. They need to understand the cost per tenant, because if they understand this well, they can then think about their own cost model, how they will monetize their solution. And if they don't get the cost per tenant right, they can fail, and it's really for the financial health of the business, it's not very good. So this is for SaaS providers. This is why you need to be able to monitor the cost. And last but not least, if you reduce or you optimize your usage of resources, your cost, you also reduce your environmental impact. And more we see organizations, enterprise, which are really into reducing their impact on the environment. So again, if you optimize cost, you optimize resource usage, and you reduce your environmental impact. So now that we know why it's important to monitor costs, we need a tool, and that's why today we will talk about Kubecost. So Kubecost is not the open source project. Kubecost is based on OpenCost, and OpenCost is the name of the project which was graduated at the sandbox level in June last year. So this is a tool which was built in order to monitor resource usage and costs, calculate cost associated with resources deployed in a Kubernetes cluster. And then you can, when you have this cost, you can break down the cost per Kubernetes resources. So think about namespace. I want to know the cost of everything which is deployed in one namespace. Or I want to know the cost for this pod or for any Kubernetes resources. So OpenCost was built for that. it has a user interface, a web interface that you can use, but it's quite simple. And that's where Kubecost come into place. It adds some functionalities like reporting, sizing recommendation for pods, for nodes. It also includes alerting. So you can configure Slack alerts or any other tools that you use to trigger alerting with Kubecost. So today, during the demo, I will use Amazon EKS. So it's a managed service on AWS to run, scale, operate easily a Kubernetes cluster. So for the demo, I will use Amazon EKS. And if you use Amazon EKS, the best way to deploy Kubecost is to use the AWS optimized bundle, which comes with some advantages, which I will present now. So first, this bundle is optimized for AWS. So it was tested by AWS, tested by Kubecost to be optimized for Amazon EKS. Then it supports Amazon Managed Prometheus. So this is a managed service on AWS for running a Prometheus server. It scales automatically. You deploy it also automatically. You don't need to invest too much time to deploy it. So it's compatible with Prometheus. And why is that important? It's because Kubecost uses as a data store Prometheus. So it's compatible with the managed services, and the managed service will be used to store the metrics, cost metrics, which are generated by Kubecost. But we will see that during the demo. Also with this bundle, you get unlimited historical data. So if you don't use the bundle and you decide to use the Kubecost free version, you will get only 15 days of history. With the bundle, you get this unlimited historical data. Then it supports also multiple clusters. So if you have multiple Kubernetes clusters and you want to monitor the cost of this cluster, you can use this bundle and monitor the cost of both or 1, 2, 3 clusters with the same instance of Kubecost. I already said that, but it supports alerting. It also, and this is quite nice, as I said, if you don't want to monitor only what is running inside Kubernetes, but you want to monitor also resources which are running in the cloud or anything else, you can integrate Kubecost to monitor or configure Kubecost to monitor those resources as well. And in AWS, the best way to get access to the cost, to your usage, is what we call the cost and usage report. So it's a daily report which is generated by AWS, where you get for all the resources that you have deployed and all the dimensions which are used to build those resources, you get the cost for each dimension, for each resources. And this is the detailed view of your cost in AWS. So Kubecost is, you can configure Kubecost to take those costs, to get those costs, and have a unified view of your cost inside the cluster and cost outside of the cluster. Also, if you run in production and you decide to use this bundle, it's supported by the AWS support. So if you call the support or you create a case with the support, this bundle is supported, which is quite nice. And the best news is that this bundle is free, so you don't pay anything additional for using it. So there is really, if you are running on AWS, there is no reason for not using this bundle, as you get more benefits than if you use a classic Kubecost free version. So that's it for the bundle. Now let's get into the details of Kubecost. So here what you see on the screen is a virtual private cloud. So it's your network if you run in AWS. And we have an EKS cluster, which is represented, and you have a pod, which is a Kubecost pod deployed in your Kubernetes cluster. And what we see in this pod is that you have 3 containers. So the first one is the front-end container. So as the name says, it's used to display the dashboard, Kubecost dashboard, reports, and the user interface for Kubecost. The second container that you have, which is more important or more critical, is the cost model container. So this one is used first to generate metrics about your cluster. So it generates metrics about your resources, Kubernetes resources, also about the underlying infrastructure, so your nodes. It generates all those metrics. And then you have at the bottom the Prometheus pod, which is also part of the bundle. And this Prometheus, okay. What was the trick?
Last time we just fiddled with the child.
Yeah. So you have this Prometheus pod, which is part of the bundle, and it will scrap the metrics generated by the cost model container. And in this mode, when you use Amazon Managed Prometheus, it will be configured in remote write configuration. So it will write all the metrics from your cluster in Amazon Managed Prometheus. So this is the first step, get the metrics, usage metric about resources inside your Kubernetes cluster. And then, so when those metrics are generated, so metrics about your usage, again, the cost model container will read those metrics from Prometheus, so information about your resource usage, will generate other metrics, cost calculation, aggregation of data, and push those new metrics again to Prometheus. So this cost model container is important to get information about your resource usage and then to generate new metrics with this cost information. And then you see here a third container, the orange one, which is the AWS SIG v4 proxy. It's just here to allow the cost model container to query the Amazon Managed Prometheus workspace. So in AWS, when you call an API, we use SIG v4 signature to authenticate the caller or the client. And this container here is just here to act as a proxy, to get the AWS credentials, and to be able to access the Amazon Managed Prometheus workspace. I want to stop here. Any question regarding how it works? Was it somehow clear? Yeah? Okay, so let's continue. Don't hesitate if you have questions. Again, as I said, it supports multiple clusters. So if you have other clusters, you can install Kubecost on those clusters, and you can feed all the metrics from both clusters into a single Prometheus instance in AWS. What I show here is it's optional. So you are not obliged to use Amazon Managed Prometheus workspace. On AWS, it's what we recommend because it will scale automatically. You don't need to manage it. But if you are in another environment, the Prometheus pod that you see in your EKS cluster will be configured as a classic Prometheus server, not in remote write, and it will store the data locally. What is not very nice about this is that if your cluster scale and you get more resources to monitor, then you need to make sure that this pod here is able also to scale. So you need to manage the scaling of the Prometheus pod. Okay, so this is it for how it works. Now we will go into the demo, but just before to start with the shell, quick overview of what we will deploy. So I have provisioned already an EKS cluster because it would take too much time here to deploy it, and that's not the interesting part. Inside this cluster, I have deployed nothing, so we will deploy everything. What I want to show here is that we will deploy multiple WordPress websites. Let's say I'm a SaaS company. My service is that I will manage WordPress for my customers. And here I will deploy multiple customers and one customer per namespace. So what you see here on the screen is that I have customer 1 or tenant 1 in the namespace WordPress tenant 1. And I have other customers until the customer number 5. And customer 1 has only one website, but customer 5 will have 5 websites. So I will deploy those customers so we can have some data also to check regarding the costs. I will also deploy Kubecost using Helm in the Kubernetes cluster. And I will also demonstrate the cloud cost integration, so how you can get the cost about your AWS resources into Kubecost and build this unified view. So let's go for the demo, the fun part. Okay. So here let's first have a look. We'll use this one. So we have some. Yeah, I didn't deploy any workload or any application pod in this cluster. Maybe I need to zoom a little bit. It's okay for people. Yeah. Okay, cool. So here, what we have here is just so the AWS node, which is deployed. It's a daemon deployed on each node of my cluster. It's used to connect to the VPC, so it's used to connect the node and the pods to the network in AWS. Then we have, of course, core DNS. We have kubeproxy as well, which is here, and we have also I forgot about this one, but we have the EBS controller, which is just a pod which are used in order to manage the life cycle of disk storage in AWS. So EBS, Elastic Block Storage. So this Kubernetes cluster has this controller in order to provision volumes as EBS volumes in AWS and manage their life cycle. So let's get started. We don't have Kubecost yet, so we will get Kubecost, the Helm chart of Kubecost from the Amazon ECR public gallery. So it's just a repository similar to Docker Hub, but with higher throttling limit. So if you have some throttling limit when you don't use the paid version of Docker Hub, you can use ECR public gallery. It has a higher throttling limit. Let's check for Kubecost, and here you can see that I have the container images which are here, but I also have the Helm chart which is here. So this is what we will use. And first, what we need to do is to log in to the ECR public gallery and get the Helm chart from there. So let's do that. So I'm using the command line here to log in to the ECR public gallery. And so now I'm logged in. So what we need now, as we will deploy a Helm chart, we need a configuration file. Because as I showed you, I want to use Amazon Managed Prometheus as my Prometheus server to store the metrics. So I need a configuration file. Let's take a look at this configuration file. So I will create this file. So what we see here as a configuration, we see that we will use AMP. So AMP is Amazon Managed Prometheus. And here I configure the AMP workspace ID. It's just the resource ID of my Managed Prometheus in AWS. So I configured this variable already. And we define the AWS region as well in order to connect to my Managed Prometheus in the proper region. So that's it for the configuration of this file. And then we can go ahead with the deployment of the Helm chart. So here what we see is that I'm using the chart which is in the ECR public gallery. I'm deploying in the Kubecost namespace. And what is important also is that I have two configuration files. The first one is a configuration file which was created in order to optimize the deployment of Kubecost in AWS. So you have other deployment files that you can find for depending on where you are deploying Kubecost, but here I'm using the one which is optimized for EKS. And then I'm using the file which I just created, config values, to configure the integration with Amazon Managed Prometheus. So let's deploy this chart. Yep. And here, maybe we can have a look if we deployed something. Okay, so we can see that I have two pods which are being deployed. I have the Prometheus pod, which will be configured in remote write mode, and I have the cost analyzer pod, which is used to generate the metrics and also to aggregate and the cost for my Kubernetes cluster. So this is still creating, and now we can see that it will be running soon. Okay. Okay, so now what we can do, we can directly do a port forward on this deployment of Kubecost and have a look at the user interface. So here you go. So here is the front end of Kubecost. What we can see here is that I don't have much data, so we just deployed it. It's kind of normal. And if we go in the monitor section here, in the allocation, I even have an error here, and this is because I didn't give the proper permission to the cost model container to access the Amazon Managed Prometheus workspace. So I need to provide those credentials, AWS credentials, to my pod for it to get access to the Prometheus server. So I will do that using a CLI, CLI, so the EKS CLI. So yeah, so you can use this command, and this command EKS CTL create IAM service account will create an IAM role in AWS. So this is just an identity which you create in AWS, and my pod will be able to use this identity to connect to the Amazon Managed Prometheus server. So I need to create two roles, one for the cost model container and one for the Prometheus pod, which is configured in remote write mode. So let's create the one for the Prometheus server. Error. Okay. So I need to just missing a variable here. Yeah. Okay, so this should be better. So here I'm creating the role in AWS, which will be used to access the Prometheus server or the Amazon Managed AMP service. And I need to create one for the Prometheus pod and one for the Kubecost pod. Okay, so let's do that. Yeah, same. So I put them in parallel so it will go faster. So if we go back to the presentation here, what I'm doing is giving permission to this pod here. I'm giving AWS permission to access the AMP service, and here I'm giving also the permission to this Prometheus pod to access the AMP service. Okay. So this one, the one for Prometheus was created, and now in the top, the one for the cost analyzer, Kubecost analyzer, is created as well. So now what we will do, we will restart the deployment, restart the deployment. So let's. Okay, let's have a look. Okay, so the Prometheus server. Oh, sorry. Yes, thank you. Okay, so yeah, so here I just redeployed the cost analyzer, which is the first pod, and the Prometheus pod, so they can use the AWS permission to connect to the AMP service. So let's have a look now again at our interface. We can use again port forward to have a look. And here we should be able, yeah, as we can see now, we have some data which is now available for us to see. So what we can see in Kubecost in the interface here is that you have an overview first about the possible monthly saving for your cluster. So this is a new deployment, so we don't have a lot of numbers, but you have this notion as well of cluster efficiency. So the efficiency is what you use in comparison with what you provisioned. You have also the total cost of everything which is running inside your Kubernetes cluster. And you can have more data like cost per namespace, cost per pod, the trend, your external cost, so cloud cost, what you are, for example, paying in AWS or in other cloud providers as well. And you can have also a network cost breakdown if you want. In the monitor section, you will have only the internal cost, so what is deployed inside your Kubernetes cluster. In cloud cost, only the cloud cost. And if you go into the report section, you can create reports. And there is a new feature in Kubecost, which is called Advanced Report Cost Center, which is still in beta. And here in this report, you can combine on the same view, the same dashboard, cost inside your cluster and cost in the cloud provider. So you could have in the same dashboard the view of your cloud cost and your Kubernetes cluster. Why is that useful? Because if you deploy an application here for a tenant, for example, we deploy an application which is deployed in Kubernetes with pods, and we also use a database which is deployed in AWS. If you want to get the cost for this particular customer, you need to be able to combine the cost of AWS and the cost inside the Kubernetes cluster. You also have a saving section. We will check it later, and other section. So now that Kubecost is configured properly, what we can do, we can deploy some application, because right now we don't have any application which is deployed. For this, I have a script which will deploy some customers. So let's say I want to deploy, let's say 3 customers inside my cluster. So now we can have a look at what is happening here. And we can see that here I'm deploying multiple applications. So those are WordPress deployments, which I'm deploying for my customers. So I will leave aside this deployment, this cluster now, and I want to show you how you can get the cloud cost and how you need to configure Kubecost in order to get the cloud cost, at least for AWS. So, before to do that, let's have a look at something that customers using or users of Kubecost do often, is to create their own dashboards to get their cost. So instead of using the dashboards which are in the Kubecost front end, they create their own Grafana dashboards. And you can do that quite easily. So if I go here to, sorry about that. Thank you. So if I go here in the account which we are using, so this one. So here I'm logging to the AWS console just to show you how you can build a Grafana dashboard on top of the Prometheus metrics. So I zoom. Okay. So I deployed already an Amazon managed Grafana workspace. So I will log in to this workspace. You can use any Grafana workspace. I will sign in here. Password. Okay. So where is the password? Should be somewhere here. Just let me get, yeah, okay. Could have made it more simple, but let's go with this one. So now I'm logging my Grafana server or workspace, and just if you are here, you can go in AMG, so Amazon Managed Grafana. You can go into Apps, AWS Data Source, and here I can connect to my Prometheus server. So I can make it a data source. Here I'm selecting it. Okay, so now it's a data source for my cluster, and what I can do now, I can just go in Dashboard in Grafana, and I can create a new dashboard, you can find this dashboard JSON on the Grafana website, but I will. So this file, which I'm just using, you can. So that's weird. Okay, so I already have this dashboard which is deployed. So let's not have a look at this one. Should be fine. Okay, so let's delete this one. So we can create a dashboard in Grafana. Let's try again. Okay, we select our Prometheus server here, and we can click on import. So okay, so here I'm just using the classic Kubecost dashboard for Grafana. As it's a new deployment, you don't have all the data yet, but this is the kind of dashboard that you can create and play with the metrics which are generated by Kubecost to generate your own dashboard with the cost which is important for you. And here what you can see, you can have the cost per container, for example, but you can also have the cost per namespace. So if we zoom a little bit in here, and as this is a new deployment, we can check the last 5 minutes, for example. Yeah. So here, as you remember, we deployed some workloads, some application into the cluster. And here you can see that I already have my cost per namespace. So as a SaaS company, for example, I can easily monitor the cost of my customers, of my tenant inside the Kubernetes cluster using this kind of dashboard. So I know here that 31% of my cost, of my Kubernetes cost, is dedicated for the namespace, workspace tenant 3, so for my customers 3. So now let's take a look at the cloud integration, how you can build that. And for that, I will log in to another account where I already made the configuration. So to get the cost, the external cost, Kubecost use AWS Athena. So it's a service that you can use to query JSON or CSV or Parquet file using SQL queries. So it's like a managed Presto service, if you want. So here in my AWS account, I have this Athena service, which is configured to be able to query my cost and usage report in AWS. So I have cost and usage report in S3. I have Athena, which is configured to query those reports. And I have a database, which I will not show now, not to lose time, but I have a database which is deployed in AWS, and I tagged this database with a tag called Kubernetes namespace. And this name is what you should use if you have resources in AWS, you want to monitor them with Kubecost, you use the Kubernetes namespace tag name, and you put the value of your Kubernetes namespace. So that way you can map your Kubernetes namespace with tags that you put on your AWS resources and get the overall cost for your application. So this is configured here, and in Kubecost, in my deployment, so here I need to log into another account. What is the name? So this one. And I will just show you to finish. Sorry. Yes, I think this is the one. So I switch to the right Kubernetes cluster, and then we can do a port forward on this one. And here I just want to show you that with this integration between Kubecost and Athena, you can easily get. So now I will switch here. Yeah, so here you can see I have already more data. I have some data about the cluster efficiency. I have some data about my consumption, my cost per namespace. And what I have here is what we call the cloud integration, but I have the cost for my AWS resources as well, which are linked to Kubecost. So you could have other providers here as well. This is just for my AWS environment. And what is nice is that now you have, of course, your cost for what is inside the Kubernetes cluster. So you can follow your cost per namespace. You can follow your cost also per label, anything you want, basically. And if I go to cloud cost, I also have the cost for my AWS resources. So for my EC2 instances, my load balancer, my database, my Kubernetes cluster, my Prometheus managed service, all those costs are now here in Kubecost. And what I can do now, I can go to the report and I can view, using the advanced report feature of Kubecost, I can view the cost for my first customer. So here I can combine on the same view the cloud cost, which are the cost of my database for tenant 1, and the Kubernetes cost, which are costs inside the cluster. And with that, that's it for this presentation. If you have questions, I think we can take them during the little apéro, maybe after or now. I don't know.